Electrical metallic tubing, or EMT, requires specific support methods to ensure its structural integrity and adherence to electrical codes. The National Electrical Code, or NEC, dictates these requirements to maintain safety and prevent hazards. The question is whether an additional EMT run can be supported from an existing run that is already supported within 3 feet of a junction box. The answer is no. Supporting one conduit run from another is generally not permitted. Let's delve into the reasons and compliant alternatives. Firstly, consider the mechanical stress. Each conduit run is designed to handle a certain amount of weight and stress. This includes the weight of the conduit itself, the conductors inside, and any potential external forces. Supporting a second conduit run from the first introduces additional, potentially uncalculated, stress. This added stress can compromise the integrity of the initial support system, leading to sagging, loosening, or even failure of the supports. The original support system was engineered for a specific load, and adding more load than it was designed for will compromise the structure. Secondly, there is the aspect of code compliance. The NEC mandates specific support intervals and methods for EMT. These requirements are put in place to ensure the conduit remains securely fastened and protected. Supporting a second conduit from the first can easily violate these requirements. The NEC specifies that conduit must be supported at specific intervals, typically every 10 feet for EMT, and within 3 feet of boxes, conduit bodies, and fittings. Utilizing the first conduit support for a second conduit might not fulfill these individual support requirements for each run. The NEC provides guidelines and tables outlining compliant support methods for various conduit types and sizes, and these requirements must be followed meticulously. Thirdly, think about the potential for vibration and movement. Electrical systems are subject to vibration from various sources, such as nearby equipment or machinery. If one conduit is supported from another, any vibration in one run can be transferred to the other. This transferred vibration can cause loosening of connections, wear and tear on the conductors, and potential electrical faults. Independent support systems minimize the transmission of vibration, ensuring greater stability and reliability. Vibration can weaken connections and cause damage over time, increasing the risk of electrical hazards. Fourthly, there are concerns with accessibility for maintenance and repairs. If one conduit is supported from another, accessing either conduit for maintenance or repairs can become significantly more difficult. The interconnected support system can restrict movement and create obstacles, hindering the ability to perform necessary work safely and efficiently. Independent support systems allow for easier access to each conduit run, streamlining maintenance and reducing downtime. Proper access is crucial for diagnosing and resolving electrical issues promptly. Fifthly, consider the issue of grounding and bonding. In electrical systems, proper grounding and bonding are crucial for safety. Grounding ensures that metallic components are electrically connected to provide a low impedance path for fault currents, facilitating the operation of overcurrent protective devices like circuit breakers. Supporting one conduit from another can compromise the grounding path if not done correctly. If the support system is not properly bonded, it can create a high impedance path, which can be dangerous in the event of a fault. Independent support systems allow for dedicated grounding and bonding connections for each conduit run, ensuring a reliable and safe electrical system. Proper grounding and bonding are paramount to prevent electrical shock hazards. Sixthly, there are specific NEC articles to consider. For example, NEC Section 358.12 outlines the permitted uses of EMT, while Section 358.30 details the support requirements. These sections provide specific guidance on how EMT should be installed and supported to comply with code. Violating these sections can result in fines, rejection of the installation, and potential safety hazards. Familiarity with these NEC articles is essential for any electrical professional working with EMT. It is best to consult the latest version of the NEC to ensure compliance, as codes can be updated. Seventhly, let's discuss compliant alternatives for supporting the second EMT run. One common method is to use additional strut or unistrut. A separate length of strut can be installed parallel to the existing run, providing a dedicated support structure for the second conduit. The strut can be attached to the building structure using appropriate fasteners and anchors. This ensures that each conduit run has its own independent support system. Strut systems offer versatility and can be easily adjusted to accommodate various conduit sizes and configurations. Eighthly, another alternative is to use individual conduit clamps and hangers. These devices are specifically designed to support EMT from the building structure. They come in various sizes and styles to accommodate different conduit diameters and mounting surfaces. Conduit clamps and hangers provide a secure and reliable support system, ensuring that the conduit remains properly fastened. They are also relatively easy to install, making them a cost-effective option for many applications. Ninthly, consider using trapeze hangers. Trapeze hangers consist of two vertical supports suspended from the building structure with a horizontal bar connecting them. The conduit is then attached to the horizontal bar using conduit clamps or straps. Trapeze hangers are particularly useful when multiple conduit runs need to be supported in close proximity. They provide a stable and organized support system, minimizing the risk of interference or damage. Tenthly, one must ensure proper spacing and securement. Regardless of the support method used, it is crucial to maintain proper spacing between supports. The NEC specifies that EMT must be supported at intervals not exceeding 10 feet and within 3 feet of boxes, conduit bodies, and fittings. These requirements must be strictly adhered to ensure the conduit remains securely fastened and protected. Proper securement is also essential to prevent the conduit from shifting or moving over time. 11thly, consider the environmental factors. In certain environments, such as those exposed to corrosive substances or extreme temperatures, special support materials may be required. For example, stainless steel or coated supports may be necessary to prevent corrosion. Additionally, expansion joints may be needed to accommodate thermal expansion and contraction of the conduit. These considerations are crucial for ensuring the long-term reliability and safety of the electrical system. 12thly, think about the importance of proper installation techniques. Even with the correct materials and methods, improper installation can compromise the integrity of the support system. It is essential to follow manufacturers' instructions and industry best practices when installing conduit supports. This includes using the correct tools, tightening fasteners to the proper torque, and ensuring that all connections are secure. Proper installation techniques are crucial for preventing premature failure of the support system. 13thly, one should regularly inspect and maintain the conduit support system. Over time, supports can loosen, corrode, or become damaged. Regular inspections can identify potential problems before they become major issues. Maintenance tasks such as tightening loose fasteners and replacing corroded supports can help extend the life of the support system and ensure its continued reliability. A proactive approach to maintenance is essential for preventing electrical hazards. 14thly, proper documentation is key. Maintaining accurate records of the conduit support system, including the type of supports used, their location, and any maintenance performed, can be valuable for future reference. This documentation can assist with troubleshooting, repairs, and upgrades to the electrical system. It can also be helpful for demonstrating compliance with the electrical codes and standards. Accurate documentation is an important aspect of responsible electrical system management. 15thly, remember to consider the specific requirements of the local electrical code. While the NEC provides a national standard, local jurisdictions may have additional requirements or amendments. It is essential to be familiar with the local electrical code and ensure that all installations comply with these requirements. Local electrical inspectors can provide guidance and clarification on specific code requirements. Compliance with local codes is mandatory for all electrical installations. 16thly, focus on worker safety during installation. Working with electrical systems can be hazardous, and it is essential to take appropriate safety precautions. This includes wearing personal protective equipment, such as gloves and eye protection, and following safe work practices. Always de-energize circuits before working on electrical equipment and use lockout/tagout procedures to prevent accidental re-energization. Worker safety should always be the top priority during electrical installations. 17thly, the weight of the conductors inside the conduit must be accounted for. The size and number of conductors can significantly affect the overall weight of the conduit run. It is essential to choose support systems that are capable of handling this weight. Overloading the supports can lead to sagging, loosening, or even failure. Consult with an electrical engineer or qualified professional to determine the appropriate support requirements for specific conduit configurations. 18thly, expansion fittings are another consideration for long conduit runs. In long conduit runs, thermal expansion and contraction can create significant stress on the support system. Expansion fittings are designed to accommodate this movement, preventing damage to the conduit and supports. They are typically required in long, straight runs of conduit, particularly in areas with significant temperature variations. Proper use of expansion fittings can extend the life of the electrical system. 19thly, it is important to choose the right type of conduit for the application. EMT is suitable for many applications, but other types of conduit, such as rigid metal conduit or PVC conduit, may be more appropriate for certain environments. The choice of conduit depends on factors such as the level of physical protection required, exposure to corrosive substances, and the need for watertightness. Selecting the right type of conduit is crucial for ensuring the long-term reliability of the electrical system. 20thly, consider the aesthetic appearance of the conduit installation. While functionality is the primary concern, the aesthetic appearance of the conduit installation can also be important, particularly in commercial or residential settings. Neat and organized conduit runs can enhance the overall appearance of the building. Using consistent support methods and maintaining uniform spacing can contribute to a visually appealing installation. In summary, supporting one conduit run from another is generally not permitted due to concerns about mechanical stress, code compliance, vibration, accessibility, grounding, and worker safety. Compliant alternatives include using additional strut, individual conduit clamps in hangers or trapeze hangers. Remember to adhere to NEC requirements, local electrical codes, and industry best practices when installing conduit supports. Always prioritize safety and ensure that the electrical system is properly grounded and bonded. Regular inspections and maintenance can help extend the life of the support system and prevent electrical hazards. Always consult with a qualified electrical professional for guidance on specific installation requirements.